Hello ladies and gentlemen, and welcome to the video lesson for Chapter 2, Section 1 in your Algebra 2 textbook entitled Relations and Functions. We should already be familiar with the idea of a relation from Algebra 1. A relation is a pairing of two variables, an independent variable and a dependent variable. So you have your input, and as you feed each number into the relation, it will put out an output that is related to that input. That's why they're called relations. So it's a pairing of an independent and dependent variable, or input values and output values, x's and y's, however you'd like to think about it. When we talk about a relation, we have a domain. The domain is a set of all the input values, or x values, values of the independent variable. And you have a range, which is a set of output values, or y values, or the values of the dependent variable. Now, when a relation has exactly one output for each input, it is known as a function. So the example that we use, the real world example, is a vending machine. When you press a button on a vending machine, that machine delivers the snack that you expect to come out. It doesn't have a chance of sending out more than one different item. And then finally, function notation. We should be somewhat familiar with this idea, the use of f of x as the dependent variable. In other words, f of x and y are the same thing. So when we see f of x, we should think that those are the same thing. They're interchangeable. Okay? So, example 1 asks us simply to use function notation. We need to rewrite each ordered pair or equation using function notation. So for ordered pairs, remember what this says. This says when x is -7, y equals 1. Well, we can do the exact same thing by saying f of x, or f of -7, equals 1. Okay? You got, again, your x is -7, your y is 1. So x goes inside, and the y goes after the equal sign. So the second one here, again, that says when x is 1/2, y is 32. That's what that ordered pair says, x comma y. We are able to write that exact same thing in function notation. Instead of x, we're going to feed in our x value, which is 1/2. And then on the other side of the equal sign would be our y value, 32. Now for an equation, it's even easier, because since f of x and y are interchangeable, all we have to do is replace y with f of x, and we have written that equation in function notation. So for letter D, f of x equals 3x squared plus 1. Okay, so first thing we need to be able to do is use our basic arithmetic and algebra skills to evaluate functions. So we have here a whole bunch of different types of examples. The first one reads, a function f is defined by f of x equals 5x plus 7. And then it says, what is the value of f of 10? So there's the question that we have to answer. What that's saying is, what is y when x equals 10? So f of 10, what we do is we plug in a 10 for every x in that equation. So we're going to replace x with 10. So 5 times 10 plus 7, well, that would be 50 plus 7, which means that f of 10 equals 57. Okay, letter B is the same sort of example. Given that f of x is x squared plus 3, find f of -2. Write your answer in function notation. So again, when it says find f of -2, it is saying, what is y when x equals -2? Which means they're supposed to take -2 and plug it in for x. So f of -2 would be -2 squared plus 3. Well, that would be 4 plus 3, because -2 squared is -2 times -2, which is 4. So f of -2 would be 7. Now, one thing to note here, remember what that's saying. If you graphed f of x, this point, 1057, would be on the graph. If you graphed f of x over here, the point negative 2, 7 would be on the graph. These are the same exact thing written in two different ways. One's written as an ordered pair, the other's written in function notation. All right, C is a little bit more advanced of a function in terms of being more difficult, more scary looking. So when we have f of 10 here, we're going to plug in 10 for every single x. So we do 10 plus 0.25 times 10 times 50 minus 10. Well, that would be 12.5 times 40. So f of 10 would be what, 500? Okay, that's what we do. We just evaluate where every single x has the value that they asked us about. And the notation f of 10 says, what is y when x equals 10? So we plug in a 10 for every single x. Okay, on the next one here, it's a little bit trickier. It says the function h is defined below. What is the value of h of 14 minus h of 10? So we need to find both of these values. So I'll do these in two different colors here. H of 14, we would plug in 14 for x. So 14 divided by 2, which means that h of 14 is 7. Then we'll do that again for h of 10. We'll replace x with 10. 10 divided by 2, so h of 10 is 5. So when it asks us for the value of h of 14 minus h of 10, that is 7 minus 5, which means the value is 2. Okay, so then on E and F, we're working in the opposite direction. In this case, it says find a value of x for which f of x equals 29. So that's saying, what is x when y equals 29? So what we're going to do is we're going to take that 29 and we are going to plug it into the function on the left side where f of x is located. So that would give us the equation 29 equals x plus 4. We've already practiced this year how to solve that equation. We need to get rid of the plus 4, so we would subtract 4 from each side, and we would find that x is 25. So in other words, f of 25 is 29. Okay? Same thing here on letter F. We're supposed to find the value for which f of x equals 17. So we're going to plug that 17 into the equation for f of x. 17 equals 2x plus 5. And solve that equation. So subtract 5 from each side. Would give us 12 equals 2x. And then divide by 2 would give us x equals 6. Which means f of 6 equals 17. X has to be 6 for f of x to be 17. Okay, on letter G, it says for function f shown below, c is a constant. If f of 4 equals negative 7, what is the value of c? Well, what they've done there is they have given us an x value of 4 and an f of x value of negative 7. So we're going to plug those values in. Negative 7 equals 4 squared plus c. So then we'll solve that equation. Negative 7 equals 16 plus c. Then subtract 16 from each side. And we get that c is negative 23. Okay, same thing here on letter H that we did in E and F. We're going to take this 40, we're going to plug it in for f of x, and we're going to solve for x. So 40 equals 1/2 x. To clear that fraction, we're going to multiply both sides by 2. and we get that 80 is equal to x, which means f of 80 equals 40. All right, so that's how we use equations. Now let's go on and talk about how to use graphs. So here we have the graph of a function. Notice that we have 4 points indicated here. We've got n points at negative 2, 4 and 10, 2. We've got a minimum value down here at 7, negative 3. And there is one more point that's definitely on the graph at 3, 1. So when we look at a problem like this and we see f of 3, that is saying what is y when x equals 3. So we go to 3, we go up and we find that point. This point is 3, 1. When x is 3, y is 1. So f of 3 has to equal 1. Remember that function notation, f of 3 equals 1, is interchangeable with your ordered pair that we just wrote on the graph, 3, 1. f of 3 equals 1. Okay, so then for f of 10, again that is saying what is y when x equals 10? That's what that's asking. What is y when x equals 10? So we go to x equals 10 here. We go up and find the point. That is the point 10, 2. Well, the point 10, 2, written in function notation, would indicate that when x equals 2, or I'm sorry, when x equals 10, y equals 2. So f of 10 is 2. All right, I'm not going to rewrite the question this time because we've done a couple now. But again, on f of 7, we would go to 7, locate the point. That is the point 7, negative 3, which means f of 7 is equal to negative 3. Again, that is interchangeable with the actual ordered pair from the graph, 7, negative 3. Okay, then we can also work backwards from a graph. Okay, so when it says find every x where f of x equals 4, we're going to look at the line y equals 4. And we're going to note any point where the function exists on that line. In this case, the point negative 2, 4 is on that line. So f of negative 2 is equal to 4, which means x equals negative 2 would result in f of x equals 4. Similarly, for 0, f of x equals 0, we actually have 2 points where that exists. We've got a point here and a point here. This point is 4, 0, and this point is 8, 0. So we would say f of 4 is 0, which means x is 4. f of 8 equals 0 means x could be 8. So there are 2 answers to that one. When you're given a y and asked to find an x, it is possible to get more than one answer. Okay, last slide. This is the last graph here. Again, you should pause the video and try this on your own before you watch me do it to make sure you know what you're doing. f of 10. Well, this point right here has x value of 10. It is the point 10, 60. So f of 10 is 60. When x equals 10, y equals 60. f of 35, that would be right here, the point 35, negative 20. So 35, negative 20 means that f of 35 is equal to negative 20. Okay, next up, f of 0. Well, 0 is right here, the point 0, 0. Okay, tells us that f of 0 is equal to 0. Alright, then we turn our attention to going the opposite direction. Find x when f of x equals negative 40. f of x equals negative 40 is this line right here. It has a single point at 40, negative 40 is that point. So since f of 40 equals negative 40, we would say x equals 40 is the answer to that question. Okay, and then we've got for f of x equals 20, that's right here. There are 2 points that fit that description, there and there. And one of them is not as easy to identify as the other. Okay? This point here is 25, 20, so that's an easy one. F of 25 is equal to 20, means x is 25 is one answer. And then the other one, well, given the rate of change and how this is a linear section, it is increasing by 60 over the first 10 seconds, gives you a slope of 6. So when we go up 20, we would have ten-thirds as the other function value. Which means x equals 10-thirds would also be an answer there. And that's very, very challenging to come up with that second point. I don't think any of the ones on your actual assignment are that hard. Thank you very much for your time and attention.